You are tuned to IRI Learning, and I am your host, Teacher. In this lesson on mixtures and separation, we will look at the separation technique, simple distillation. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to determine the properties of the components of mixtures that permit separation by simple distillation and explain the process of simple distillation. Let us do a quick recap. Remember that the components of a mixture are separated based on their physical properties, which include particle size, crystalline shape, boiling point, solubility, magnetism, sublimation, density, and other properties not noted on this particular list. Simple distillation is not a very common everyday technique used in the home to separate substances. However, we indirectly experience it daily through the natural occurrence of the water cycle, which involves the two processes, evaporation followed by condensation. So what exactly is simple distillation? Simple distillation can be defined as the process of obtaining a pure solvent from an impure mixture using evaporation and condensation. What property allows for the separation of the components of a mixture during simple distillation? Simple distillation actually uses the difference in the boiling points of the components of the mixture. Now we will examine the apparatus setup and procedure for simple distillation. We will also state the function of each apparatus used in the setup. Here is the apparatus setup for simple distillation. We will begin with the labels for wire gauze and tripod stand. Note that the wire gauze is a metal mesh that sits on top of the tripod and provides a surface for the experiment flask to sit on. And the tripod stand provides support as well as it has a space for the heat source to get under the experiment flask. Next, we have the round bottom flask and the thermometer. The round bottom flask is also referred to as the RB flask. RB, of course, representing round bottom. And this is a container in which the solution or the impure mixture is placed. The thermometer records the temperature at which the solvent evaporates, and it is held in place by a rubber bong or a thermometer adapter. Notice that the bulb of the thermometer is located in the region where the solvent vapors enter into the condenser, right where we have this red flashing arrow. Hence, the thermometer records the temperature of the pure solvent vapors entering into the condenser. Note that the RB flask is usually 1/3 filled with the impure solvent or the solution being used in the experiment, and that boiling chips, also known as anti-bumping granules, which are usually tiny glass beads or some kind of inert material, are usually added to the solution, and this prevents bumping. That is, it prevents that furious popping up of the solution during boiling. As the solution is heated, the liquid or the solvent particles break the interparticle forces and they escape into the gas state. And the vapor rises into the RB flask. As we can see here, the vapors are rising up towards the thermometer and entry into the next part of our apparatus setup. As the pure solvent vapors rise, eventually they enter into the condenser. The condenser consists of a narrow inner tube enclosed by a larger outer tube, and the larger outer tube has two arms, a lower arm and an upper arm. Now, water enters the outer tube, the larger outer tube of the condenser, through these arms. Now, the water is used for cooling, so we refer to it as cooling water. So the cooling water enters the outer tube of the condenser through the lower arm. It circulates the narrow inner tube, then exits through the upper arm of the condenser. As the water circulates around the narrow tube, it cools the vapors, passing through the narrow tube, changing the vapor to the liquid state. Note that the cooling water runs continuously for the duration of the experiment. Connecting water to the condenser. The water enters through the bottom arm of the condenser and circulates upwards around the inner tube, then exits through the upper arm. Note that the water does not come in contact with the content of the inner tube. It only serves to cool the content of the inner tube while circulating around it. The vapor cools and condenses, changing into a pure liquid within the inner tube of the condenser. The pure liquid is collected as the distillate, and we usually collect the distillate in a container such as a conical flask, also known as an Erlenmeyer flask, or even a beaker. Simple distillation. Here we have a simple distillation process already in progress. As the impure solvent is heated, the vapor of the pure solvent escapes the mixture. The vapor rises and eventually reaches the condenser. As the vapor enters the inner tube of the condenser, it is cooled by the water circulating over the surface of that inner tube. The vapor condenses, changing to the liquid, which is collected as the distillate. So we can look at some of the uses of simple distillation. Simple distillation is commonly used in the purification of liquids such as solvents. So it can be used in producing drinking water from seawater or other impure sources, as well as in producing distilled water, which is used in batteries of vehicles. We're at the end of our lesson, so let's do a quick summary. Simple distillation is commonly used to separate a pure solvent from an impure sample. During simple distillation, the components of a mixture are separated by the difference in their boiling points. Simple distillation involves two processes: evaporation followed by condensation. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Which statement is correct about the function of the thermometer during simple distillation? The thermometer records the temperature of the A. distillate, B. impure solvent, C. pure solvent vapors, D. the apparatus or glassware. The answer is the thermometer records the temperature of the pure solvent vapors during simple distillation. Question 2. Identify the statement that is correct about the distillate during simple distillation. A. The distillate is the pure liquid collected. B. The distillate is the impure liquid collected. C. The distillate contains impurities. And D. The distillate is heated to extract the pure liquid. The answer, of course, is the distillate is the pure liquid collected. Question 3. Why are boiling chips added to the impure solution during simple distillation? A. The boiling chips remove impurities. B. The boiling chips increase the rate of boiling. C. The boiling chips lower the boiling point of the distillate. D. The boiling chips prevent vigorous bumping during boiling. The answer there is the boiling chips prevent vigorous bumping during boiling. Question 4. What property allows for the components of a mixture to be separated during simple distillation? A. Particle size. B. Boiling point. C. Density. D. Crystalline structure. The answer is B, boiling point. That is, during simple distillation, the components of the mixture are separated according to the differences in their boiling points. Question 5. Which two processes are involved in simple distillation? A. Evaporation and boiling. B. Evaporation and freezing. C. Evaporation and sublimation. D. Evaporation and condensation. The answer is D, evaporation and condensation. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with iRe Learning.